and the second one is actually working, of the orchestrating the cloud with Kubernetes over the AWS. Okay, so let's come up to it. Let's get to the first task. Wait, activate Cloud Shell? Yes. Okay. Setup and requirements. Open Google Cloud Console in incognito window. Accept permissions. That was for some extension. Okay, login with the student, and the password is right there. Yeah, I agree for everything. Okay, so how to start your lab and sign in. Skip that part. Now activating the Cloud Shell, of course, is by pressing this button right there on the navbar. Now GCloud is the command line tool for Google Cloud. It comes pre-installed on Cloud Shell and supports tab completion. Okay, let it set up. Now GCloud, got it. GCloud auth list, authorize. Okay, we got some active account. Now optionally you can list the project ID with this command: GCloud config this project. Okay, we should get a output similar to this one. Yeah, it is. Okay, now to the Google Kubernetes engine in the Cloud Shell environment, type the following command to set the zone. Okay, let's set it up by hand. GCloud config set compute / zone US East 4-B. Warning, property validation was skipped. Okay, updated. Next, start up a cluster for use in this lab. GCloud container clusters create IO. Okay, default change, VPC native in default mode, creating cluster IO in US 4, which is the zone we set before. Okay, let's wait for it to finish. Cluster is being configured. Can I add a new window? Okay, let it finish in this tab, and on the other one we will continue with the task, which is the getting the sample code. Start with common gsutil cp-r. Now the path for over the file we want to pull. Now slash and over our current category, which is presented by ALE dot. Okay, the files are getting copied. Let's come to this tab before where the cluster was being created, and it's still updating itself. That's how would I say that. Okay, files got copied from over the source code. Now next, change into the directory needed for this lab. So cd change directory orchestrate with Kubernetes / Kubernetes ls ls. It gives us the folders inside this directory, and yeah, they are the same as on the example. So we can come up to the second task of quick Kubernetes demo. The easiest way to get started with Kubernetes is to use the kubectl create command. Have the cluster got created? Now create a cluster IO in US East. Okay, whatever. So now let's write this command of running the of this command that will launch a single instance of the container. Kubectl. Let's hide the navigation menu. Kubectl create deployment. Now nginx image equals nginx version 1.10.0. Error, failed to create deployment, connection refused. Is that because the cluster hasn't got created or something? Master is healthy. Okay, cluster is being health checked. Master is healthy, working. Okay, it's still working. Okay, note, it will take a while to create a cluster. Kubernetes engine is provisioning a few virtual machines behind the scenes for you to play with. Okay, so all we can do is to wait. Great. It takes a lot of time. Okay, let's come to YouTube. Mr. Beast. He built 100 houses and gave them away. Okay, let's see. Skip that ad. Jamaica. Okay, he gave away 100 houses. That's amazing. Leave a like and a follow. Good job, Mr. Beast. I'm your biggest fan. Okay, so as the Okay, let's leave it like that so you can see the whole console. This GCloud shell terminal. Okay, so as the kubectl got started, or what was it? Yeah, a cluster has started up. We can now come up to these comments and start with kubectl create deployment over the nginx container. Now we will use the kubectl get pods to view the running nginx container. Okay, there is it. It is already running by 20 seconds. Now once this container has a running status, you can expose it outside of Kubernetes. Okay, status running, yes. So now run kubectl expose deployment nginx -- port 80. With a type of load balancer. So what just happened? Behind the scenes, Kubernetes created an external load balancer with a public IP address attached to it. Any client who hits that public IP address will be routed to the pods behind the service. In this case, that would be the nginx pod. Now list our services using the kubectl get services command. Yeah, we got two services running. One is Kubernetes and second one is this nginx load balancer. Now it might take a few seconds before the external IP is populated for your service. This is normal. Just rerun kubectl get services command every few seconds until the field populates. Okay, once again. Okay, external IP got exposed. Now we need to copy it and use it with the curl command http/IP address and then port 80. And we got this response of the welcome to nginx. If you see this page, the nginx web server is successfully installed and working. Great. Let's complete this task. Right. Third task, pods. At the core of Kubernetes is the pod. Pods represent and hold a collection of one or more containers. Generally, if you have multiple containers with a hard dependency on each other, you package the containers inside a single pod. Okay, that's how it looks like. Now, fourth task, creating pods. Pods can be created using pod configuration file. Take a moment to explore the monolith pod configuration file. Okay, come to the Orchestrate with Kubernetes and then Kubernetes. And now run the cat command of listing a content of the file. Cat policy pods monolith YAML or something like that. Okay, the output looks like this. And now there's a few things to notice here. You'll see that your pod is made up of one containers name monolith. Yeah, that's true. You're passing a few arguments to our container when it starts up. Arguments are these secret equals secret health and HTTP that are deployed over different ports. And now you are opening up port 80 for HTTP traffic. Okay, now create the monolith pod using kubectl. We have to write kubectl create -f pod / monolith .yaml. Damn, I misspelled that. Okay, now the path got created. Now we have to examine them by writing kubectl get pods. And we have two pods running. One is nginx and now second is monolith. And it is already running, so that's cool. And once the pod is running, use kubectl describe command to get more information about the monolith pod. Okay, let's run that. kubectl describe pods monolith. And there is this whole info page with the events and volume and event conditions. Great. But we come to the next task of the interacting with pods. And by default, pods are allocated a private IP address and cannot be reached outside of the cluster. Use the kubectl port forward command to map a local port to a port inside the monolith pod. So open a second CloudShell terminal. Now you have two terminals, one to install port forward command and the other to issue curl command. In the second terminal, run this command to set up port forwarding. So I have to run kubectl port forward monolith, and now what is written there? 10,080 by 80. And in the first terminal we have to run a curl command over the HTTP 127.0.0.1 and over the port 10,080. And we got a message equal hello. So now let's see what happened when we write this command over the path of secure. Authorization failed is our response for that. So how about login path? And now we also got a authorization failed. So, but let's see, at the login prompt, use this super secret password equal to password to login. Okay, so I have to run password. Could not resolve host. No, it's not this. Since CloudShell does not handle copying long string queries, well, create an environment variable for the token. Okay, token equals $, $, and then curl the HTTP response. Okay. Enter host password for the user. It was a password. Okay, so we got some data here. Now use this command to copy and then use the token to hit the secure endpoint with curl. So we are curl -h authorization receiver $token, and now HTTP /127.0.0.1 comma colon 1080 and now secure, and we got a message hello this time. At this point you should get a response back from our application letting us know everything is right in the world again. Yeah, that's true. Okay, now let's log the logs of our monolith pod by running kubectl logs monolith. Okay, we got these logs over our routing, and now we have to come up with the third terminal, and let's see how would it respond with the -f flag for monolith. Are they any different? Not really. To get a stream of the logs happening in real time. Okay, -f give us the real-time logs. And now if you see curl in the first terminal to interact with the monolith, you can see the logs updating in the third terminal. Let's see. Okay, first terminal is this one, and now we have to run this curl, and we should get here the live response. Yeah, that's it. Okay, so it is working. Okay, next, use the kubectl exec command to run an interactive shell inside the monolith pod. This can come in handy when you want to troubleshoot from within a container. Okay, so it is kubectl exec monolith -std in -tty -c monolith bin. Okay, I actually don't know how it should be written. Okay, I like this space over before the /bin. And now, once we've come to this interactive shell inside the monolith pod, we can like test external connectivity using the ping command, ping -c free google.com, and we get some response. Be sure to log out when you're done with this interactive shell. Yeah, of course, right exit. Now, next task is services. Pods aren't meant to be persistent, they can be stopped or started for many reasons, like fail liveness or readiness checks, and this leads to a problem. Okay, the level of access a service provides to a set of pods depends on the services types. Currently there are 3 types: cluster IP, node port, and load balancer. Okay, 7th task of creating a service. Before we can create our services, first create a secure path that can handle HTTPS traffic. If you have chain directories, make sure you return to the this directory, run this command. Okay, I'm already in there. Now exploit the monolith service configuration file by cat pod/secure monolith.yml. It's looking like that. Okay, great. Now create the secure monolith pods and their configuration data. First one would be kubectl. I have to copy it all. Kubectl create secret generic TLS source -- from file TLS. Then kubectl create config map nginx proxy conf from file nginx proxy.conf. And then kubectl create -f paths /secure monolith.yaml. Let's hit that command. And yeah, the secret got created, the config map got created, and also a path got created. Now let's come over to the monolith.yaml file. It's looking like that. And things to note there are that the selector, which is used to automatically find and expose any pods with the labels app monolith and secure enabled. Now you have to expose the node port here, because this is how you forward external traffic port from 31000 to nginx on port 443. So for that, use the kubectl create command to create the monolith service from the monolith service configuration file. Okay, say no more. Kubectl create -f services /monolith yaml. So what's next? Now we should get output of the service monolith created. Yeah, check my progress. And now let's read. You are using a port to expose the service. Normally Kubernetes would handle this port assignment. In this lab you choose a port so that it's easier to configure health checks later on. Use the GCloud compute firewall -rules. Okay, GCloud compute firewall -rules create allow -monolith -node port / allow equals TCP : 31000. Wait, what? Minus allow, and it's wrong. Okay, let's copy. Like, what? Allow monolith node port / allow equals TCP. Oh, once again. What? Never mind. Okay, the firewall is being created now. Then after this job will be completed, we can check the progress of allowing traffic to the monolith service on the exposed node port. Yay, complete. Okay, now first get an external IP address for one of the nodes. So GCloud compute instances list. So for one of the nodes, external IP1, second and third one. Okay, now try hitting the secure monolith service using curl -k https : copy some IP. Let's take this one, then and over the port 31,000. Where to connect? Okay, it's not this one, maybe this 34.48.194.14. Not this one either. Okay, so the bottom one 48.136.30. Not even this one. That timed out. What's going wrong? It's time for a quick knowledge check. Use the following comments to answer the questions below. So first one, kubectl get services monolith. Okay, cluster is running, but its external IP is set to none. And now kubectl describe services monolith IP1 IPs. Okay. Questions. Why are you unable to get a response from the monolith service? How many endpoints does the monolith service have? Endpoints? None. What labels must the pod have to be picked up by the monolith service? Labels? Labels none also. Okay. Hint, it has to do with labels. You'll fix the issue in the next sections. So now we are adding labels to pods. Okay, so first run kubectl get pods -l, and now app equals monolith. And we got these two pods of the monolith and secure monolith. But what about app equals monolith and secure enabled? Okay, so after the app equals monolith, let's write a secure equals enabled. No resources found in default namespace. So now use the kubectl label command to add the missing secure enabled label to the secure monolith pod. Afterwards you can check and see that your labels have been updated. Okay, first one, kubectl label pods secure -monolith secure equals enabled. Now kubectl get pods secure -monolith show -labels. Okay, so the label of the secure equals enabled got added to the secure monolith pod, and it's now correctly labeled. And now we can see that let's try to see the list of endpoints over the monolith service. kubectl describe services monolith, and let's use all the grab endpoints command. And yeah, we got a endpoint of this IP, and now test this out by hitting one of our nodes again. gcloud compute instances list. Okay, and let's try to now curl any of the IP, any of these IPs. https / copy this colon 31,000 message hello. Okay, on the first one. How about second? 4894.14 again. And how about the third one? 38.136.30 and again message hello. So it seems like we added labels to pods correctly, and we can access them. Okay, that's cool. Check my progress. Great. Task number 9, deploying applications with Kubernetes. Okay, deploy. Pods are tagged to the lifetime of the node they are created on. In the example above, node 3 went down, taking a pod with it instead of manually creating a new pod and finding a node for it. Your deployment created a new pod and started it on node 2. Okay. It's like on this image. So now task number 10, create a deployment. Okay, so get started by examining the auth deployment configuration file. Cat deployments /auth.yml. Okay, it's something like that. And now the deployment is creating one replica and you're using version 2.0.0 of the auth container. When you run the kubectl create command to create the auth deployment, it will make one path that conforms to the data in the deployment manifest. This means you can scale the number of pods by changing the number specified in the replicas field. Okay, now let's run the kubectl create -f deployment /auth.yml. The path, okay, I misspelled it again, deployment /auth.yml, and it got created. Now kubectl create -f services /auth.yml, and it will be a service for our auth deployment. Now we will do the same thing to create and expose the hello deployment. -f deployment hello, and also the kubectl create -f services /hello.yml. Now and one more thing, time to create and expose the front-end deployment. Kubectl create config map nginx -frontend -conf -from file equals nginx/frontend.conf. Okay, the config map got created. Now kubectl create -f deployment /frontend yml, and again kubectl create -f services /frontend yml. Now there is one more step to creating the frontend, because you need to store some configuration data with the container, and to interact with the frontend by grabbing its external IP and then curling to it, use a kubectl get services frontend. Okay, we got, no, external IP is still pending. Note, it might take a minute for the external IP address to be generated. Once again, yeah, the external IP has appeared. Now let's run the curl command over this address 34.48.206.176, and yeah, that's all. And we got message hello again. So the task has been completed. and we successfully created auth, hello and front-end deployments. Let's check the progress. And yeah, congratulations, in this lab we learned how to create a Kubernetes clusters, deploy and manage Docker containers using kubectl, and break an application into microservices using Kubernetes deployments and services. Great to hear that. Now we can finish the lab. Okay, cannot leave the comment, but we can come to the next step, or I would like to come back to the first one because I have to skip it today. And that is all for this video, this stream. No matter how you watch it, and see you next time. Bye.